All right, so let's get this party started with 1106 College Mathematics, talking about Exam 1, which covers Chapters 2 and Chapters 3. So the first questions from question 1 all the way to question number 11, those are all Chapter 2 questions. And then from question 12 all the way to question 25, those are all your Chapter 3 questions. So let's start hitting these questions up. So question 1, so it wants you to express the roster method of this. So in other words, it wants to know what are all the elements in the actual set. So a couple things to talk about. First off, you got to remember what this bold letter N means. So that is your natural numbers. Remember, natural numbers start at the number 1 and work their way on up. There are no decimals, no fractions. You do not contain 0, and you do not contain any negative numbers. You are what we call the natural numbers. That's what that large N stands for. Natural. Okay? Then we talk about these symbols that are right in here, these inequality symbols. Because it is written in this fashion with a small number first and a large number second, that means what you're looking at is that you're stuck between two numbers. You're stuck between this 7 and 11. But the question is, do we like the number 7 and do we like the number 11? Well, that's what these circles around these symbols in green are for. They tell you whether we actually like that number and include it or do not like that number. So down here at the 7, because it is not equal to, that means that we do not like the number 7. That means we're going to start right beside the number 7. And since 7 is our lowest number, we're going to go right to the number that's right above it. So what number is right above 7? 8. So that's the first number our set will start at, because we do not like the 7 according to that symbol, the less than, and which means that we're going to start at the number 8 that's right above it, because we are stuck between 7 and 11. So now as we count up, so then we got 9, 10. Now the next question is, do we like 11? So when we look at this symbol, it has the equal to under it. So we are less than or equal to. Because we are equal to, we got the line underneath the inequality symbol. That means we like 11. That means we include it because we can be equal to it. And then that's where our set will stop. So all you have to do is find the set over here that matches the 8, 9, 10, and 11. And that is A. Everybody else has way too much information or not enough information. So like answer B, it includes the 7. And we know based on the less than symbol up above, that was right here, that we do not include 7. And then down below C, all these dot, dot, dots means that it keeps going on and on and on and on. So what you can see there in C, that means that we're going to have negative numbers below the 5 and all sorts of numbers above 14, which we already know that we were supposed to be stuck between 7 and 11. And then the last one says that it is the null set, the empty set, which means that we have no answers, but obviously we have answers. We have 8, we have 9, we have 10, we have 11. So that means that we can't have the empty set be a part of this. All right, moving on to question 2. Question 2, so you're looking at this. We have 4 choices over here, and this is all about subsets. So this symbol right there, that means subset. And this symbol right there means that it is a proper subset. Okay? Just one thing to tell you right off the bat. You can never, ever just have a proper subset. It's impossible. Because in order to be a proper subset, you have to be a subset to begin with. So that's why this answer that I circled right there will never ever happen. So now you have like a 1 in 3 shot of being able to get this correct. Okay? So now you have a 1 in 3 shot of being able to get this answer correct, because you can never ever just be the proper subset symbol. You either are a subset, or you're both, or you're none of them. Okay? So remember, to be a subset, to be this guy right here. That means that all of the elements in the first set must be in the second set. Because to be a subset, it means that you're pieces of the original. That's what a subset is. It's just pieces of the original. So when we look over here, R, S, and C, are R, S, and C in the second set? Yeah, they're right here, R, S, and C. So that means that this first set is definitely a subset. So now we know it's either this answer right there or the answer that's down below it. So now we just got to ask ourselves one other question. Is it a proper subset? In order to be a proper subset, that means that you cannot be equal. So are these two sets equal to each other? And no, they're not. Because to be equal, that means you have to have the same number of elements and they have to be the same elements. So the cardinality is the same and the elements themselves are the exact same. And since RSC is not equal to RSCT, then that means we know that we are also a proper subset. Because again, to be a proper subset, you cannot be equal. If they were equal, that means you would not be proper. So our answer is both. Because it is a subset to begin with, and it's not equal, which makes it proper. Okay? So there's question 2. All right, question 3. So from here, we want to know, is the set 9 an element of the set that's on the other side? So that's what this little symbol right there means. This little E means is an element of. So is the set 9 an element in the set after it? And absolutely, look right here. Set 9, set 9. It matches. So this element is in the set, which means that this is a true answer. Okay? Be careful, because if you had something like this, 9, an element of the set 9, and the set 16, this is where you would have a false answer. Because the element 9 is not an element in the set. This does not mean the same as that guy. They're not the same. This is an element of the number 9. This is the set 9 as an element. Completely different. This is just a number. This is the set 9. So that would be a false answer. But because these two matched up here, set 9, and in here I have a set 9, it's an element of it. All right, list all the subsets. List all the subsets. So just make sure that whatever you select has everybody that should be accounted for up here. So as subsets, remember you can just have each of the elements. So element A is a subset because that is a part of that. Element J is a subset because that is a part of it. Element W is a subset. Okay? And then I could start combining elements together. I could have the set AJ. I could have the set AW. I could have the set JW. And it doesn't matter the order of those. If you have JA, that's the same thing as AJ. If you have WA, that's the same thing as AW. So it doesn't matter the order. And then I could have all three of them in there because the set itself is a subset of itself. This is the guy that I was talking about earlier. This would not be a proper subset because you are equal to the original set. So this is the guy that would not be a proper. Everybody else that I listed before it is a proper subset because they're not equal. And then there's one more. The empty set is always a subset of the original. So which one of the answers is it? A. Because that is the one with all the subsets I have listed out. Any questions on that one so far? All right. So from here, moving on. Question number 5. So again, this is where I would be making a Venn diagram of this. And then look at the Venn diagram to answer everything. Remember, I kind of gave you an order of operations to this. So the order of operations, that's what the OOO stands for. The first thing you're going to take care of is parentheses if you have them. The second part you'll take care of is the complement. The third piece you will take care of intersections and unions. Okay? So I'm going to make a Venn diagram first. The box represents the universe. And inside we will have 2 circles because we have 2 subsets over here. That's what the A and B are. They're your subsets. So remember, when you make your Venn diagram, you start in the middle. Start in that middle piece. So what do both A and B have? 1 and 2, absolutely. So I'm going to put 1 and 2 in the middle. Cross those off because they are no longer usable. Okay? Then we work inside A. So what numbers are left in A? 3 and 4. Cross those off. What numbers are left in B? 5. Cross those off. And who is hanging out in the universe? 6 and 7. Because those are the only numbers we didn't cross off. And now we're ready to start going through the questions. So we look down here. We got A intersect B. So we don't have any parentheses. We don't have any complements. So we actually just have to deal with the intersection. So the intersection is where the 2 circles overlap. It's what both circles have in common. And so what do both circles have in common? 1 and 2. And your answers, when you put them in, they will want them in ascending order, even though this doesn't say it. I'm pretty sure it wants it in an ascending order, meaning smallest to largest, and you put a comma between your answers, if there's more than one answer for it. Okay? So let's take a look at number 6. It's going to be a lot of the same process. All we did is change it to letters this time instead of numbers. So again, we'll make that Venn diagram. And then we'll go through that order of operations that I had up there a second ago. Again, you have 2 circles, A and B, because those are the subsets we have in there. So, start in the middle. What do A and B have in common? W and Z. You got it. Cross those off because we can't use those anymore. What's left in A? So the C goes in the A part, cross it off. What's left in B? F goes in the B part, cross it off. And who is hanging out in the universe? There you go. H, M, Q, S. Now we can start answering our questions. So notice it's a little bit more involved this time. Okay? So again, we always go back to those. I always use those order of operations when I go through this. So order of operations, OOO. First you work with parentheses. Then you work with complements. And then you take care of your unions and intersections. So looking at what we have right here, we have parentheses. So I need to take care of those first. Inside my parentheses, do I have a complement? No. But I do have an intersection. So I can figure that information out. A intersect B. So what is in the intersection of A and B? W and Z, because that's what they have in common. W and Z. Okay? And now, since we've already done the parenthesis part, now we start to do the outside part. So we need to take care of the complement first. So complement means give me everybody that's not in that set. So in this case, I need all the letters that are not in B. So that means the W, the Z, and the F are all out. Because W, Z, and F are all in B. So what letters does that leave us with? There you go. C, H, M, Q, S. And then now you take care of the last part, which is the union. So what is the union between those two sets? So union means I want everybody in both of those. So give me everybody in both of these sets. W, Z, C, H, M, Q, S. Perfect. Because that's everybody in both sets. Okay, I'm sure it will probably want it in alphabetical order. So there is a way to kind of put this in ascending order. So you start with your C, then your H, M, Q, S, W, Z. Sure, that's probably how they would want it. So always make sure that you read those fine print directions that are right under your answers when you're putting them in to make sure that you are putting them in correctly. Otherwise, it will count it wrong, even though you might have the right letters. Okay, or numbers. All right. 7 is kind of nice for us because they've already done the Venn diagram. All we have to do is answer the question. So again, thinking about that order of operations. Start with parentheses. Take care of complements. Then deal with your unions and your intersections. So, do we got parentheses? Yes. Then we're working inside there. Inside my parentheses, do I have any complements? Yes. Inside the parentheses. No, the complement's on the outside over here. So don't worry about that yet. But I will take care of the union in here. So I need the union of A and B. I need everybody in A and everybody in B. So what numbers are in the circles A and in the circles B? Uh-huh. Yep. Okay. It's okay. 8's there too. Yep. 14. And I wrote 16 instead of 14, but yes, it's in there. And 20. So there's everybody in A union B. Okay, that's all the numbers in both circles. Okay, so now we're over here. Now we've done the parentheses. Now we start working outside the parenthesis. So outside my parenthesis, do I have a complement? Yes. We need the complement of what we just wrote. So I need all the numbers that are not listed above. I need all the numbers that are not listed in the set that we just wrote. This thing is so touchy sometimes. 23. 27. Good. Yep. 42 and 49. Good. Because that's the complement of the set that's above. These are all the numbers that are not in there. And then, now we're going to go ahead and take the union of set A and what we just found right there with the complement. So I like to write out what set A is, even though you can look at the picture and know. So what all numbers are in set A? 1. What else? Yes. Yes. Yepers. 14. Yep. 16. So what we want now is the union between those two sets. Between this guy right here and that one right there. So what would the union complement? So what are all the numbers we're going to list? Yes. Yes. Yepers. Yep. 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 Perfect. And that's what it's looking for. That's the answer. So basically, you are writing down every number but 20. We wrote down every number but 20. That's what's everything that's in here. Okay? There we go. Let's talk about number 8. Number 8, again, we're going to do the same thing, except our Venn diagram has just gotten a little bit bigger. Instead of 2 circles, we have 3, because we have 3 subsets. Just got a little bit bigger. That's all it did. We're going to do the same process over again. Nothing new has come your way. So how I do 3 circles is I make the 2 circle and go into the middle of the intersection and I draw a circle downward. That's how I make my 3 circles. I make my 2, go into the middle of the intersection, draw a circle downward. All right. So I'm going to call this guy A, B, C. And where do we start to fill this in at? You start in the middle. Always start in the intersection, and you work your way out from there. So what do all 3, A, B, and C, have in common? If anything, maybe they don't. Well, but I want to know about what all 3 of them have in common. Nothing. So don't put anything in the middle. All right, move on from there. So up here, so there's nothing in common in here, so don't put anything. In this square right here, in this section right there, what am I asking about? Just A and B. So what do A and B have in common? If anything. Nothing. Move on. So there was nothing in there, there's nothing in there. What about in here? Who is that about? Do B and C have anything in common? 2. Anything else? 4. There we go. So there's what's in common from B and C. 2 and 4. And we're going to mark those off. Now up here, notice they got some dot, dot, dots. I'm going to write these guys out to the side. 4, 5, 6, 7, 8, 9. Oops, so I don't need the 9 because I already had it. That way I can cross off numbers as I take care of them. So we took care of the 4 over there. All right. What's this guy about? A and C. Do A and C have anything in common? 1. Anything else? 3. So there's what A and C have in common. Cross those off. All right. Now, up here, what is left in A? 6 and 8. Good. 6, 8. Cross those off. What's left in B? 5. Good. Put a comma between these so that way you don't think it is 13 or 24. So we said 5. Good. Mark it off. Gone, gone. What's left down here in C? 7. Perfect. So 7's gone. Is there anything in the universe? Who? 9. 9 was the only number we didn't mark off. So it's out there in the universe. So here's what our Venn diagram looks like. Now we can answer our questions. And again, we're going to do that order of operations that I've been talking about again. So we're going to start with parentheses. Then we will move on to complements. And then we will do unions and intersections. Okay? So when we look up here, do we have any parentheses that we got to take care of? Yes, right here. We got to take care of that. Do I have any complements in that parenthesis? No, not inside it. That complement, that little apostrophe is outside it. So inside, we got to take care of the union. I need the union of A and B. So I need all the numbers that are in A and B. Who are they? Okay? Okay? 5, 6, 8. Anybody else? Yep. 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 There we go. So we also have 1, 3, 2, and 4. Those are all the numbers that are in the circles A and B. Okay? Yes, I know 1 and 3 and 2 and 4 are in C, but if you also look at those, 1 and 3, 2 and 4 are also in A and B, and that's what we want. We want everybody in A, everybody in B. So now we've taken care of our parenthesis. So now we work on the outside. So we're going to take care of the complement on the outside now. So I need all the numbers we didn't list. So who is that? 7 and 9. That's what the complement is. Give me everybody else. So there's our complement of the union. And now we're going to look at the intersection between set C and the set that we have above. And again, I'm going to write out what set C is. And you actually already know it's right over here. There's set C. So it's 1, 2, 3, 4, and 7. So we want to look at the intersection between these two. So what is it that these two sets have in common? If anything. 7. There's your answer. That's all you're going to put inside your brackets or braces. You're going to put 7 because that's the only thing they have in common. Cool beans? All right. Number 9. Again, same idea, but this time they've already made the Venn diagram for us. Yay. So what we want to know is we want to know the answer to this. So not very difficult. There's no parentheses. There's no, complements. You're just talking about B union C. And again, union means give me everybody in them. So I want all the numbers in B and C. So tell me what they are. 6, 7, 10, 11, 13, careful, 12, 13, because these directions definitely say give it to me in ascending order. So 12, 13, anybody else? 15, anybody else? There you go. And there's your set. That's what they want. That's it. Give me everybody in B and C. And that's 6, 7, 10, 11, 12, 13, 15, 17. Because those are all the numbers in those two circles. All right. Number 10. Okay, number 10, again, they've given you the entire Venn diagram. All you got to do is answer this question right here. So they want the intersection of all three. So what do all three have in common? 18. Right there. That's the intersection. That's what goes in there. Okay? If you need to, you could break this down and do the intersection of A and B first, and then take that and intersect it with C. So what do A and B have in common? 6 and 18. And then if you look at C, C has 10, 12, 16, 18, and 19. So the intersection of all of these, what do both of those sets have in common? 18. Lots of ways to look at it. You can always break it down into smaller pieces and work towards the whole. But all it really wanted was, it wants to know what's in the center. What's in the center? All right. So last question from all of chapter 2. And it's a word problem, just like the word problems that you dealt with in class and on your assignment. It's all about rock, jazz, and classical. So, because we have 3 ideas, you have 3 circles. Rock, jazz, classical. And as you do this, you start where? In the middle. So, what do we know about all 3 styles? There are 13 students. So I'm going to cross that off, and I'm going to put 13 in the middle. And that's the only number from this problem that you will use straightforward, the way it is. Everybody else from here on out, we need to do subtraction to, because we will have started to count some of these. Like right now, we have 13 students accounted for all of these sections that are going on. So now we're going to start to work our way out. So I'm pointing right here to that little square right there where I put the green mark. That's all about rock and jazz. What do we know about rock and jazz? There are 26 students. It's right here. Rock and jazz, there are 26 students. But you already have 13 taken care of. So how many students are really in that green section right there where I have the dot? 13, because 26 minus 13 is 13. Okay? 26 of these students we need, but we already have 13 taken care of. So you can see what I mean by from here on out, all these numbers that you see up in the problem are going to change. You're going to have to subtract from them because you already have students taken care of. This is the only problem in the entire exam where you want to use that calculator. Everything else there shouldn't be any calculator work on because there's nothing to do on the calculator. This is the only one where I encourage you to use your calculator and all you're doing is adding and subtracting. All right, so right here, another green section right in there. That is jazz and classical. What do I know about jazz and classical? There are 15 students. So how many are with this green dot? 2. Because 15 minus 13 is 2. So we've taken care of that sentence. Now this last green dot right there, that's rock and classical. What do I know about rock and classical? There are 15 students total. Again, you already have 13 taken care of, so how many are left? 2. There we go. And now we're going to continue to progress outward. So, now, right here, this is all about rock students, where my black dot was. This is all about rock. So, what do I know about rock students? There were how many? No, there were 41. There are 41 rock students. But again, we already have some of these taken care of. We have 13, 13, and 2, which is the 28. Is that what you're giving me? No. Okay, no worries. So we already have 41, we have 41 students for this circle, but again, you already have 13, 13, and 2 taken care of. So how many are left? Well, 13 plus 2 is 28. 41 minus 28 gives us what? So again, this is where I encourage you to use that calculator. We'll do it by hand real quick. 3, that becomes 11. 11 minus 8 is 3, and 3 minus 2 is 1, so There are 13 students in here. And if you add 13 plus 13 plus 13 plus 2, you should get 41. Okay? So again, I encourage you to use your calculator on that so you don't have to do any of that work by hand. But you should be able to do it by hand. Okay? So now we're going to look at this piece right there. So that's about jazz. How many jazz students were there total? 36. There are 36. But we already have 13, 13, and 2 taken care of. So we already have 28 out of those 36 taken care of. So 36 minus 28. So that'll become 2. That'll become 16. So we have 8 students left in jazz out of the 36, because we already had 13, 13, and 2 taken care of. And still moving on, notice that we're getting down to the last few numbers. So all we have left right here is classical. And you can see that right here. There were 28 classical students. But we already have 2, 13, and 2 taken care of. So that's 17. So we're going to take the 28 minus 17. And that gives us 11. When you subtract those two. And now you might feel like your work is done, but if you look carefully at your problem, you have one more number. Right here. There were 93 students that we talked to. You already have 13, 13, 8, 2, 13, 2, and 11 taken care of. You need to add all these numbers up. 13 plus 13 plus 8 plus 2 plus 13 plus 2 plus 11. And subtract that from 93. So I'm going to scroll down just a little bit. And we have the following numbers that we're adding. 13, 13, 13, 8, 2, 2, and 11. Again, I would use your calculator on this. Once we get this total, we will subtract that from 93, whatever that total is. So, looking at what we got here, we've got 3, 6, 9, with the 1 down below, that makes 10. 8 and 2 right here make 10. So that's 20, 22. Carry the 2. And then it's 2 plus 1 is 3, plus 1 is 4, plus 1 is 5, plus 1 is 6. So we have 62 students total taken care of. So 93 minus 62, 31 students are left out in the universe. Again, use your calculator, double check that. And you want to double check these numbers because everything that you're going to do from here is all based upon this Venn diagram that we made right there. And these numbers that we have found. There we go. Copy. I'm going to go to the next page because I got to paste this over here. Because we're going to need this for these questions as well. So all these questions that you see over here are all based upon that information for 11. So you got 6 questions that need all this information. Okay. So let's start answering some questions here. So it says, how many listened to rock music only? That answer is right there. Those are the only students that listen to rock music, so that's 13. Now, be careful on B and C. They look like the same question, but they are different. And they're different because of that word there and that word right there, or. They will have different answers, so be careful on this. So up here it says, how many listen to classical and jazz? What are we talking about when we talk about that and there? We are talking about the intersection. So you're looking at the intersection between classical and jazz. And then over here it says, but not rock. What does the not mean for us? complement. Not negation yet. We're not in that section yet. So the not means it's the complement. That means we want to kick out the rock. So when we look at the intersection, that's right here. There's the intersection between classical and jazz. But one of those numbers in there we got to throw out. Who is it, the red or the green? The red, because the red, the 13 that's in there, that includes rock. And according to our sentence over here, we don't want the rock. So our only answer to this one is 2. There are only 2 students that listen to classical and jazz, but not rock. The next guy, again, like I said, this looks the same, but it's not. It's a slight change. So what do we mean by those that listen to classical or jazz? That's a union. So again, we're going to look at the union of those, but not rock means we're going to throw out the rock again, the complement. So here, union means that we're talking about everybody in the jazz and classical circles. But we're throwing out some of these numbers. Which numbers are we going to throw out? The 13, which one? Both of them, the red and the green 13s that are right there. Because both of these are in what? The rock. Who else are we throwing out? Well, that number's not even highlighted, so we don't worry about that. We're going to throw out this 2 that's right over here, because this 2 is also in rock. So the only ones that we're really concerned with in the end are those that are right there. Those are the only ones we're concerned with, because those are the ones that are in classical and jazz, but not rock. So what is 11 plus 2 plus 8? 21. See how those answers are completely different just by changing one little word from and to an or. Completely different idea. All right, jumping over to number 11. Again, we're using the same Venn diagram, just answering a couple different questions. So over here, we have how many listen to exactly one of the musical styles? So what numbers are we talking about there? 13? Which one? What color? Black. Yep. And 8? Yep. And 11. Because those are the students that listen to only one type of music. The 13 up here was just rock. The 8 over here is just jazz. The 11 down at the bottom, that's just classical. So if we add all those up, 13 plus 11 plus 8, what do we get? You get 32, because 13 plus 11 is 24, plus 8 is 32. All right. Now the next question says, how many listen to music in exactly 2? Again, that word exactly 2. So which ones are we talking about now? What? Okay. So there's only the which 2? Both of them or just one of them? Both. Okay. So he's exactly 2. This is exactly 2. Anybody else? And the 13 up above, the other green. So all the green numbers are exactly 2 styles. So we add all those up. What's 13 plus 2 plus 2? 17. Good. I've also seen this question. They might change the word exactly in here to at least. If they change it to at least 2, then that means you're talking about everybody that's inside here. All of those guys that are in here. because all the green numbers represent 2 styles. The red number represents 3 styles. And when you say at least 2, that means you start at 2, but you could be more than that. You could be 3 styles, 4 styles, 5 styles, so on and so forth. So if you see the word at least, then you would have added all the greens with the red. Okay? And that would have given you 30 as an answer. So be careful. Make sure that you read carefully. Sometimes they use exactly, but they might throw in the word at least. And then down below, how many did not listen to any styles of music? 31. That's your universe number. So 31. So you can see how this picture, you need to make sure that you get your numbers right. Otherwise, it's going to throw a lot of things off in the end for you. So be careful on that one. And that ends right there, all of chapter 2. So now we're going to jump into chapter 3, which is all about truth table and logic statements. So this one right here, this is not the nicest of problems. To be honest, I don't really like this quantifier question being on there because there are many ways that you can answer this. And in my class, I gave you guys a set of notes that talk about, how you can express this as their answers. So in here, the first thing that they want you to do is express this sentence that's right up here as an equivalent statement, meaning it needs to be the same. So, not all people are breathing. Not all people are breathing. How that is written as a equivalent statement, and it's just something that you need to know, is that some people are not breathing. Some people are not breathing. That is the equivalent statement to it. Okay? So these are all about those quantifiers, all, some, not. Okay? And in your book, there is a page. I get this page, and that's what we want. Those are the statements that they're looking for. They're looking for an exact statement here. So, some people are not breathing is the equivalent statement to that. And then right below that, it says, give me a negation. So again, this statement up here that I have circled, they want the negation of this. So, not all people are breathing. So the negation of that would be all people are breathing. So there's the negation to those. Again, that's why I don't think this is a very fair question, because it's got to be exact. I think some of these kind of say the same thing. All right. So there's question 12. All right, question 13. So here, this is where you are going to do the symbolic form. Change these to symbols. So this is what you did in, you did a little bit in 3.1. You also did this in 3.2. So P up here is telling you it is snowing outside. Q is all about the stove is hot. So it says it is snowing outside. Who is that? P. Or, what does that look like? It looks like a V. Absolutely. The stove is hot. Who is that? And that's what they want. PVQ. Okay, so you're just taking the statement they give you, and you're turning it into symbols. So 14. So here they want you to run a truth table on this. Now the thing about this one is you're not doing all cases. You know if these statements are true or false. So up here when you look at P, it says 6 plus 5 equals 11. Is that true? So we already know that P is true then. Down here it's on Q it says 6 times 10 equals 60. Is that true? So we now know that Q is True. So we're only going to look at this truth table where P is true and Q is true. You're not doing everybody. So we want to know what is the truth value to this negate P or negate Q when the P is true and the Q is true. So remember when I talked about these in class, I gave you your own order of operations for these. And again, you're going to start with parentheses. Then you'll move to negation. Then you'll move to ands and ors. And then you'll move to your conditionals. And then the last piece you will do is the biconditional. That was the order of operations. So when we look at this, do I have any parentheses? Nope. Do I have negations? Yes, and let's work these from left to right. So we have a negation P. What does a negation do to a truth value? It turns it to its opposite. So in this case, it becomes false. And then we also have a negation Q, right? So it takes the Q column and turns it to its opposite. So what's the opposite of a true? False. So there's our negations taken care of. And now we move on to our next step. Do I have any ands or ors? Yes. Which now it's going to take care of the rest of it. So now we want to know P or Q. So we're going to take these two columns that are right here and use it to help us out with that. So ors are only what when what? Ors are only false when both are false. So looking at my two columns here, I have false and false. So that leads us to a false. So what is the answer to this? Is it true or false? It's false because my final green column over there was false. There you go. Truth table. All right, number 15. And a lot of this, basically from here on out, is all about completing the truth table. All this is all about completing the truth table. And these will all be drop-down menus in here. So in here, you will have a drop-down menu. See your little arrow. And when you drop it down, it will either say true, false. And you pick which one it is. Okay? So in here, if we're looking at what's going on, so the first column is all about negating Q. So here's Q. Let's negate it. So what do I get in my column? False. Then. And then. Good. Masterful. And now, what does this V mean right there? Or. So we're looking at P in the negation Q column, and that's what's going to help us get that column. So again, we just said a moment ago, ors are only false when both are false. So when we look at here, I've got true and false. So what does that give me? True. Because it's only false when both are false. I got true and true. What does that give me? I've got false and false. Yepers. And I got false and true. And there you go. That's what they're looking for. Fill in your columns with the proper symbols. Okay? It's a 50-50 shot on all of these. All right, 16. So the first thing it wants us to do is it wants you to put this symbol right here, this statement right here as symbols. Okay? So let's do that. So right here, it says, you did not take out the trash. So remember in class, I put a little box around the not, because that's a highlighted word for us. What does that symbolize for us? Negate P. I see an or, so I usually put my circle around that. And what's the or look like? Like a V. And then it says, you left the room a mess. Q. Good. So there's what it looks like in symbols. So you can kind of come down here and narrow down your answer. So right now it's between C and D. Now you just got to make sure that you read it correctly. So the Q looks the same for both of these, but it's the P you got to be careful of. One of the P values says you took out the trash. The other P value says you did not take out the trash. Which one represents the real P value? It is not D. Because D is the negation of P, right? D has the negation in it. So the real P value, the real P is you took out the trash. Because we want P without the negation in it. So what is this P statement up here without the negation? Take out the word not, and you got the P. So you did take out the trash is the real P value. Okay? So take out that word not. So this one, the answer is C. Be careful on that one. I know how this guy down here can throw you off, but that's not the real P statement we had up there. When you gave me this sentence, this was the negation of P because of the word not. Take out the word not, and that's the real P statement. All right, so now that we know what we're dealing with, we know that this is the symbolic notation. And the next part, all they want you to do is run the truth table and tell me a set of conditions right below that. So let's run the truth table. So right here it says we're going to negate P. Okay? Okay. Yippers. Yeps. Okay? And then now we will take Q and we will take the negation of P and we'll use it to get that column. Again, it's an or, so that means it's only false when both are false. So we go true, false. False, false. True, true. False, true. All right, so down here it says use the table to indicate one set of conditions that make the statement true. Well, we have lots of conditions up there, right? We just need one of these down here to be the answer. So you could talk to me about this one. You could talk to me about this guy or that guy. So what are the conditions that make this one right here true? What do we know about P and Q? Both have to be true. P is true. Q is true. What were the conditions for the third row? There you go. P is false. Q is true. What were the conditions for the fourth row? Both are false. P is false. Q is false. So see if any one of those three answers is down here in your A, B, C, D. So up here it says statement is true when P is false, Q is true. Did I have one of those up there? Yes, right here. P is false, Q is true. P is false, Q is true. There's your answer. It's A. Because if you look at the next guy, it says P is true, Q is false. That's not over there. It's either true, true, false, true, or false, false that we want. So that answer's thrown out. There are no conditions when we're true. Well, that's not right. We have 3 of them. And the statement is true for all conditions. That's not right, because we have a false condition that's right here. So you see how you just narrow down your answer. All right, so there is number 16. Number 17. So again, you're going to run a truth table, but they make things easier for us because they tell us what P, Q, and R are. So we already know that P is true. We know that Q is false. And we know that R is also false. All we want to do is run the truth table for what we have up here that is given to us. So again, order of operations for this thing, since there's no truth table there. Remember, the first thing you're going to do is parentheses. Then you'll take care of negations. Then you'll take care of ands and ors. Then conditionals. And then biconditionals. So if we look at up here, do we have parentheses? So we need to take care of what's inside of those. Do you see any negations in the parentheses? Nope. Do you see ands and ors in the parentheses? Yes. So the first thing we're going to take care of is the or statement. That is Q or R. So we're going to look at Q and R, and that's going to help us with this column. Again, it's an or. We've been talking about ors for the past few problems. It's only false when both are false. So I have false, false. False. Good. Now, we have finished with the parentheses. So now we work on the outsiders again. So on the outside here, do I have any negations? No. Do I have ands and ors? Yes. So this time I got to take care of the and. So we got P and Q or R. So this time we're looking at the P column and the or column, and that will help us get that answer. Now, ands are only what when what? They're only true when both are true. Only true when both are true. So I have true to false. What does that give me? False. You got it. There's your answer. So up here was the statement false or true? So you fill in the top guy. All good to go. All right. So there's 17. Number 18, we're going to fill in the table. Okay? So again, it's already taken care of all the order of operations for you, so we just start running it. So the first thing is we need to negate Q. So that will help us answer that. And what do we get in our columns? Then what? Next. Yep. Cool. All right. Now we move on to the conditional statement. These are the ones that you have to be very, very careful of. Okay? So we're going to use the Q and the P column to help us out to answer this guy. But what do we know about conditional statements? There we go. Not the conditional, but the consequence. So it is only false when the antecedent is true, the consequent is false. Again, you are only false when the antecedent is true and the consequent is false. Who is the antecedent? The P or the Q? The Q, because it comes before the arrow. So I'm going to put ant by Q, because it is the antecedent. Then that means the P is the consequent. And that is true because it comes after the arrow. The antecedent is before the arrow. The consequent is after the arrow. So when I look at this, I'm going to be looking at it from the antecedent column to the consequent column. So I go from true to true. What kind of answer is that? That is a true answer. I go from false to true. That is true. I go from true to false. That's the false answer, because my antecedent is true and my consequent is then false. That's the false guy. And then I go from false to false. There we go. Be careful on the conditional. It's going to be the one that if generally there's kind of a hiccup in, that's the hiccup, because you look at it from the wrong column to the wrong column. Order is important on that. And then now we're at the end. So now we're going to take these two columns right here and pull an and on them. So ands are only what when what again? Only true when both are true. So I got false true. Yepers. I got true true. Yep. I got false false. And I got true true. There we go. And there we are. That's what they want. Construct the truth table. Okay. Number 19. Again, it's all going to be about a truth table, and then it's going to ask us another question about, is it a tautology, a self-contradiction, or neither? So we'll talk about those here in a second. Let's first take care of our truth table. So they kind of skip one of the parts that I would normally put in here. They don't have the negation of P and negation of Q up here. I'm going to put those columns up here. I would definitely look at those when you're doing this, because it will help you remember some things. But just be careful on this. They don't always put all the columns that I think you should have to look at. So the first thing that we're going to take care of, we're going to take care of our parentheses. So you're looking at the P and Q here. So these two columns will help us with this guy. Again, we just talked about this. Ands are only true when both are true. So true, true. True, false. Yep, it's false. False, true. And false, false. Now this is where I'm saying right here, I think you need to look at the negation P and the negation Q. So I'm going to add that column right over here. Negation P, negation Q. Because we'll use these two columns to help us with that or statement. Okay? So negation P just becomes false, false, true, true. Negation Q is false, true, false, true. So we'll use these two columns to help us with the or. Ors, again, we've been talking about those for a while. Ors are only false when both are false. So I got false, false. I got false, true. I got true, false. I got true, true. Good. And now we take these two columns and we'll perform an and on them. And again, we've talked about ands. Ands are only true when both are true. So I've got true, false. Whoa, stuff is moving. False, true. False, true. False, true. So now we talk about our words down below. Tautology means that everybody was true. Obviously, this is not a tautology because everybody was false. Since everybody was false, that falls under the definition of a self-contradiction. If you're not a tautology and you're not a self-contradiction, you're neither. Okay? So again, tautology, everybody's true. Self-contradiction, everybody's false. That's what we had here. We had the self-contradiction. And neither only happens when you're not one of those two. Okay? Number 20, again, back to a truth table. And they want to know, are they equivalent? So the only way to be equivalent is if both in truth values are all the same for every case. So we need to find the truth values for this, and we need to find the truth values for that one. So we're going to run a truth table. We only have two items that we're dealing with, P and Q. And it's true, true, false, false, and true, false, true, false. So let's go ahead and work with the blue information. So again, thinking about my order of operations. You start with parentheses, then you move to negations, then you take care of and/ors, then you take care of conditionals, and finally, in the end, biconditionals. So when we look up here, obviously there are no parentheses for my blue one. Do I have any negations? So I need to take care of negate Q. So that gives me false, true, false, true. And then, do I have any ands or ors? Nope. Do I have a conditional? So now we're actually taking care of the rest of it. P, conditional, negate Q. So who is the antecedent according to that conditional? P. That's my antecedent. Who is the consequent then? Q. And again, we'll use these two columns to help us answer that one. So, we're going true to false. What does that get me? That's our false case. Because again, when the antecedent is true and the consequent is false, your answer is false. That's the only time a conditional is false. All right, now we're going from true to true. Now we're going from false to false. And false to true. There we go. Now, as long as my red statement over here matches that exactly, it's equivalent. If it does not match false, true, 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 not equivalent. So, now we're going to look at our red statement over here. So, we need to take care of the negate P first, because we don't have that column. So, we're going to negate P, and that will give us false, false, true, true. And then, going through our order of operations up here, there's no ands and ors, but we do have a conditional. So now we're taking care of the whole thing. So we're going Q, conditional, negate P. So who up here is the antecedent now? Q. So I write ant above it. Consequent is negate P. All right. So we're using these two columns to help us answer that one. So we are going from true to false. Nope, false. You got it right the first time. Because again, my antecedent is true. My consequent is false. That is our only false case. Okay, so far these guys are matching. False and false. Okay, our next one goes from false to false. True. And again, we're matching. We've matched in the first one. We're matching so far in the second one. So far, these are still equivalent. The moment this last column messes up, we're going to say not equivalent. All right, so now we're going from true to true. True. And again, we're still matching here. We are true and we are true. And then our last column, we're going from false to true. What is that? That is true. So notice my very last column here matches. So again, you look at our columns right here. This column matches this column exactly. So they match exactly. Okay. So that means that these are equivalent. Because my two columns match exactly. All right, number 21. So, here it wants to know what the inverse, the contrapositive, and the converse are. So, here is your original piece. So this is what we are calling the conditional up here. Grab and move that out to the side. Okay. Maybe it doesn't want to do that. So that is our conditional right there. So let's mark this up. I see an if, that means there's a then. So that's our arrow. He flies to Montreal. What is that? That's just P. He is in Canada. So that's just Q. That's what our original piece looks like. So now, converse means that you're going to take the Q and the P and switch them around. Okay? So, down here, which one is the converse then? It is B, because our Q was he is in Canada, so that no goes first. Our P was he flies to Montreal. That now comes after the then. And so that's what B does. If he is in Canada, then he flies to Montreal. That's the converse, because we have switched the P's and Q's around. All right. Inverse means that you're going to negate the P and then negate the Q. So which one down below represents the inverse? It is B again. Because again, our P statement is he flies to Montreal. The negation of that is he does not fly to Montreal. Our Q statement is he's in Canada. The negation of that is he is not in Canada. And B is the only one that has that in the correct order. If he does not fly to Montreal, then he is not in Canada. All right, the last piece, basically the contrapositive, it's like we take the converse and the inverse and we put them together. You're going to negate Q and then negate P. So which one over there is the negation of Q and then the negation of P? Again, it's B. Because all you're doing is taking the inverse statement and switching it around like the converse. So if he's not in Canada, then he does not fly to Montreal. There we go. That's it. That's all I wanted. 22. This wants the negation of the statement up here. Okay? So the first thing that you need to do is take this and turn it into symbols. Okay? So it is not the case that, remember in class I told you that means what? Negation followed by a parenthesis. That whole statement means that. A negation followed by a parenthesis. And then over here, now we start writing our statement. You are asleep. P. Sounds great. Or, looks like a V. You are in class. Q. And then you close your parenthesis. So that's what we're looking at. We want the negation of this statement. In other words, we want to use De Morgan's law. Remember in class I told you De Morgan's law is kind of like distributing, but it's not really distributing because distributing means we multiply, and we don't multiply logical symbols. That's just weird. Okay? But it's going to be like you distribute it through, but it affects everybody. Okay? So it's like, remember, negation means can be the opposite. So what's the opposite of a regular P? A negation P. What's the opposite of an or? An and. And what's the opposite of a Q? A negation Q. So that's the statement that we're looking for down below. We need something that says negate the P up here, you are asleep, with the word and then a negation of Q. You are in class. So what is the negation of you are asleep? So I need something down here that says you are not asleep. And that leaves you with B and C. And then the next symbol has to be an and, right? Well, now you know which one it is. Has to be C. Because that's the one that has you are not asleep and then the word and. And then if you look at the last piece, that is the negation of Q. Because you are in class, the negation of that is you are not in class. And that's what they're looking for. They want you to run the law. It's kind of like distributing, but I use that word distributing loosely because we're not really multiplying. The idea behind a negation is you give me the opposite of what's going on. All right. 23 and 24, these all come from section 3.7. These are all talking about is it a valid argument or not. So, some of you, your professors might have shown you a chart that you can look at. Okay? They may or may not let you use the chart on your exam. So that's completely up to your professor. But all of these, 23 and 24, can be done with a truth table. If you're not allowed to use the chart. So the first thing is, for all of these, we need to write our sentences out. Okay? And if you read down below right here, it's telling you some information about P. P is all about Mike got sick. Q is all about needing an extra hand. Okay? So if we look up here, this says Mike got sick. Who is that? That's all about P. I see an or, so what kind of statement is that? A V. We need an extra hand. Who is that? Q. So your first statement up here looks like P, V, Q. Okay? Then right here it says, today we need an extra hand. Who is that? Q. Then we've got a therefore. That's what the three dots mean, therefore. And then it says, today Mike did not get sick. So that little not is important to us. What is that? Negation P. So again, you could go to your table if you know the table or are allowed to use the table and look and see if this is valid or not. But if you don't have the table, that's what we're going to be doing for the question here. We'll run a truth table on this and by looking at its symbolic form. So when you draw a truth table to this, we need to turn this into its symbolic form. So here's how all of this information right here transforms. Each one of your statements above my blue horizontal line right there goes inside the bracket that you will create here. And each statement that is up here really is kind of like in its own parenthesis. And they're separated by ands. So my first parenthesis looks like P or Q. And then there's an and. And then you write your second statement, which is Q. So that's the first part. Take all of your guys that are up here above the therefore, and you put them inside a bracket separated by ands. The 3 dots that are right here become a conditional arrow. And then after the arrow, put the conclusion. So, negate P. That's what they're looking for right here at the end of these guys. Whichever one you select, you need to write that answer in. So, everything that you see right here in black, this is what goes in one of those 2 blanks. So all you have to do now is just figure out if it's valid or not. So that's where we run the truth table on this. So we got P, we got Q, and we're going to work from there. Okay, again, we've got my order of operations. So you start with parentheses. That also includes brackets. Brackets are the same thing as parentheses. You move to negations. You move to ands/ors. Then you deal with conditionals. And then you deal with biconditionals. So, we're true, true, false, false, true, false, true, false. So, do I have parentheses? Yes. We actually have these brackets that are right here. But then you work inside of those. Inside these brackets, do I have parentheses? So we're going to start between these 2 parentheses right here. This is where we start. So inside those parentheses, do I have any negations? No. Do I have any ands or ors? Yes, I've got an or, right? So we need to do P or Q. So as we've talked about, ors are only false when both are false. So true, true. True. True, false. False, true. And false, false. There we go. All right. Now we continue to work outside. So we've taken care of the inside parenthesis. Now we're going to take care of everything in our brackets. In our brackets, do we have any negations? No. Do I have any ands or ors? Yes, you got an and. You got to take care of the and now. So now we're going to take care of our brackets. So we're going to take care of, we've already taken care of the P or Q. And we want to do an and with the Q. So here, we're going to use these 2 columns right here to help us answer that one. So again, ands are only true when both are true. So we got true, true. We got false, true. We got true, true. We got false, false. All right. So we've taken care of our brackets. Now it's time to start working outside of that. So outside of my brackets, my parentheses, do I have any negations? Yes. Well, that goes to negate P. So, and that goes false, false, true, true. So do I got any ands or ors on the outside now? Nope. Do I have a conditional? Yes. Conditional is the arrow. So now we're actually taking care of the whole thing. So now we're looking at the whole thing. So we got our bracket, P or Q, and Q, bracket, arrow, negate, P. So we're going to be using these 2 columns to now help us answer that one. Who up here is the antecedent? The bracket part. So this is the antecedent. Who is the consequent? The negate P. All right. So, again, only false when both are, only false when the antecedent is true, consequent is false. True, false. That is our false case again, because the antecedent is true, the consequent is false. False, false. That's true. True, true. False, true. So the question is this argument valid? And according to that truth table, it is not valid because I have a false answer. Remember, in order to be valid, you have to be a tautology. Everybody should have been true in the end for that to be a valid argument. So because of this right here, that's why the argument is invalid. And all this stuff that you saw in black right up here, should be written down in the blank for the invalid. Okay? All of that should be written down in the blank for the invalid, because that's the answer we selected. All right, question 24. So we need to translate this first sentence. All right, so the big thing is right here is this is necessary for. That right there means that we have a conditional. But the thing is, for this conditional, everything is written backwards. Okay? So this right here is actually the consequent. And over here, this guy is the antecedent. Okay? So, when you're looking at this, since this is the antecedent, this is what they're going to call P. Since this is the consequent, this is what they will call the Q. Okay? So we really do have a P arrow Q here, but our P that we have up here is really about an engineering position. And our Q that we have up here is really about having a college degree. So when we move to the next sentence, it says you have a college degree. So who did they give you? The consequent, which we called Q. And now, this part right here, this word so for us, that represents the therefore. So that's what's going to go under our line. And then it says you have an engineering position. So that matches the antecedent up here, which is what we called the P. So here's what you have. And so if you're looking at your multiple choice and you're going across, this is the one that they wanted you to mark. Okay? So be careful of this word is necessary for. It means everything is written backwards. So this is really the antecedent. This is really your consequent. If it says is sufficient for, that's the one that's written in the correct format, where the antecedent is first and the consequent is second. But because of this guy right here, everything is backwards. So now all you have to do is determine if this is valid. If you have access to the chart for the exam, if you look at the chart, you will find out this is actually invalid. This guy is actually invalid because it is a fallacy of the converse. If you do not have access to the chart, then you will be doing a truth table. So you will set up your true statement with this. So you have a bracket. Each statement goes inside the bracket with an and. Then it will be a therefore, because that's what the three dots will represent for us, the therefore. Then your conclusion, which is P. So again, each one of these parentheses right here are each one of our statements. So P, arrow, Q. And then your other statement was Q. So this is the truth table that you will be looking up. And since it was invalid, in our truth table, we'll have at least one false answer. It won't be a tautology, because remember, a tautology is what was needed to be valid. So if we run our truth table on this, we only have two statements. We've got P and Q. And so it goes true, true, false, false, true, false, true, false. Okay? So then from here, we need to work within our parentheses, and we have a conditional right here. This is the antecedent. This is the consequent. So in this one, remember that a conditional is only false when the antecedent is true and the consequent is false. So true, true, and this is the antecedent. That's the consequent. I like to mark that up. So true to true gets us true. True to false, that's the false statement. False to true is true, and false to false is true. Okay, now we don't have to really worry about that because we already have the column Q here, but we do the and. So now we're doing pretty much the entire bracket piece. But remember that ands are only true when both are true. So we're looking at these two columns right here to help us out with that. So true, true, well that's true, because the ands are only true when both are true. False, false, well that's false. Then we got true, true, so that's true. And then we have false, true, so that is false. And now, again, we're at the very, very end. We're going to take care of the conditional again. So we have our bracket parenthesis here, P arrow Q, and Q, conditional P. So again, if we're looking at this guy, this is the antecedent part right here. This guy over here is now the consequent. Okay? Remember, conditionals are only false if the antecedent is true and the consequent is false. So, it goes from true to true, so that's true. It goes from false to true, so that's true. It goes from true to false. Right there is where you can stop, because this will be an invalid argument because we just got a false. But if you do look at the last statement, false to false is true. So because of this guy right here, that's what makes it invalid, because it's not a tautology. Done. Last but not least, you are doing Euler diagrams. Euler diagrams. This is your 3-8. So the first thing is, let's talk about this first sentence. It says, all snakes have forked tongues. So because it is an all, that means you have a circle within a circle. We have that going on. Who is the inside circle? Snakes. The bigger circle is forked tongues. Okay? That's what all snakes have forked tongues look like. Now, we're going to take this sentence and integrate it with the other picture. So this one says, no pigeons have forked tongues. No means that the circles are separated. So what two circles have to be separated? They cannot touch whatsoever. The green circle, which is who? Pigeons. And pigeons cannot touch who? The tongues, the forked tongues. So my big circle F here and my little circle P here, they cannot touch each other. Now the question you have to ask yourself, is there any other way I can draw this picture but still make sure that snakes is inside fork and pigeons cannot touch forks? No, there's no other way. If you wanted to try and put the pigeons inside here and not touch the snakes, or put the pigeons inside the snake circle, you couldn't do that because that means pigeons would have forked tongues because they are inside the circle. So you can't do that. And you can't have the pigeon circle overlap the F circle because, again, that goes against this guy right here. This one right here makes sure that pigeons and forked circles have nothing in common. So the last question that we have to ask ourselves is this true in our picture? No pigeons are snakes. Yes, because the pigeon circle and the snake circle are not touching and never will touch. So is this valid or invalid? This is valid because it is true for all my pictures, even though I only have one picture. So remember on this one, it is possible that you might draw more than one picture. In order to be valid, this final statement has to be true for everybody. Every single picture. So since we only had one picture, and it was true for that picture, that's why it's valid. And that's your exam.